Hello and welcome everyone to this podcast on epigenetics. In this podcast we're going to talk about regulating methylation at specific gene loci. So we've talked in this series on DNA methylation about how DNA is methylated, how it's regulated, how once a gene is methylated, how does that prevent transcription. But now we want to address this question of, we have, say, some 23,000 odd genes in our genome. We don't want all of those genes turned on and or off in all of our cells. So within any given cell, which gene loci get methylated? How do we determine that? And so let's draw our DNA here. I won't draw it as a double helix like I usually do. I want to draw here some histones on this DNA, like so. And as we look at these histones, remember they're like any other protein. They have an N terminus and a C terminus. And on this N terminus of these histone proteins, they have an interesting property. Because of where they're at and how they are exposed, they can be modified by various mechanisms. These modifications provide information to the cell regarding which genes to activate and which ones not to activate. Now, up to this point in these series of podcasts on methylation, we've talked about how DNA can be methylated. We've been all about methylating the DNA. But now I'm going to talk about what happens if we methylate the histone, the protein. So specific lysine amino acids, the single code for lysine is K. So specific lysine amino acids at the N terminus can be methylated. And a very important one that is methylated here is on histone 3, lysine 4. So moving from the N terminus to the C terminus of histone 3, at the fourth position there's a lysine, and it can be methylated. In fact, it can have upwards of 3 methyl groups added to that one lysine. When we see a methylated histone, that's a sign that the gene is either upregulated, meaning it's turned on, it's active, or it's about to be, meaning it's capable of being upregulated. So when DNA is methylated, it's usually a sign it's being downregulated, the gene expression. But in this case, methylating the protein, the histone, indicates an upregulation. So how is methylating this histone linked to DNA methylation? Because this podcast and the previous podcasts have been on DNA methylation. Well, let's remember that DNMT's job is to add methyl groups here. And when it adds methyl groups here, expression of these genes is downregulated. If we want to activate this gene, we need to get rid of those methyl groups, or at least prevent methyl groups from being added. So how do we go about doing that? Well, one way that this is done is by methylating histone 3 at the lysine residue. Once this histone is methylated, DNMT can no longer methylate the DNA. Somehow, methylating this histone blocks DNMT from binding here and methylating the DNA. And when that happens, when DNMT is effectively inhibited, this gene can now be expressed. Methylation of DNA, gene expression is down. Methylation of the histone, gene expression is up. So the next question may pop in your mind is how? How does DNMT know that it cannot bind here? Or what is actually preventing DNMT from binding here to methylate that DNA? And we're going to bring back an old friend here we haven't talked about for a while, and that is DNMT3L. Remember, that's that regulating DNMT. What we think is happening here is that it binds to that N-terminal tail of histone 3. When it binds to the N-terminal tail of H3, it recruits DNMT. However, if the histone is methylated, DNMT3L cannot bind here. Let me draw that out. So we have our DNA here and our histones here. If it's going to be methylated, we have DNMT3 here. And we have the N-terminal tail here. DNMT3L binds to that N-terminal tail. When it binds to this N-terminal tail of histone 3, DNMT3 is recruited. And it's recruited here to add the methyl groups to the DNA. Now let's just draw a nucleosome down here. And let's say this nucleosome is methylated on the third histone at that lysine residue. DNMT3L is still here, but it no longer recognizes that tail. And if it can't recognize that tail, then DNMT3 is never brought into that area. It's just out here waiting for a place to land, but it can't land here because DNMT3L is unable to recognize its target. If it's not methylated, all those other things can't happen, and now this gene is on. I should mention over here, this gene is off then. Okay, that's all I have for this podcast. If you have any questions about this or the preceding 3 podcasts on DNA methylation, please make sure you come see me. I'll be happy to help answer any questions you might have. If not, I'll see you in class.